Okay, one more calculation. I think we'll be done with chapter 13. What is the density in grams per centimeter cubed of silver? Okay, same silver as before. It still has, remember we just calculated the radius, and we're not going to use the radius, but it was 144 picometers. So the radius, let's see, there we go, there's a radius is 144 picometers. And we calculated, or we knew the length of a side was 407 picometers. If you're not sure where those numbers are coming from, go back and watch the previous video. And we have a face-centered cubic cell. Okay, so now we're going to calculate the density. So let's remember what density is, first of all. Density is equal to mass over volume. Well, we're not given a mass and we're not given a volume, so what the heck are we going to do? Well, the mass, that's just the mass of the atoms in the cell. Okay, so if we know the mass of the atoms in the cell, we can figure out, well, that's our top term. And volume, that's just the volume of the cell. So that's really all we need to do. Okay, figure out the mass of an atom, of the atoms in the cell, and then the volume of the cell. So let's start with the mass. Okay. So first thing we need to know is how many atoms are in that cell. Well, the red and green, they're all silver. So let's count them up again, just like we did before. So there's 1, 2, 3, 4, 5, 6, 7, and then back there buried, there's an eighth. So that's an eighth of an eighth, or I'm sorry, that's 8/8, excuse me. So that's one atom plus, let's count up those halves. There's 1, 2, 3, 4, 5, and then back there's a sixth one. So there's 6 halves, so that's 3 more atoms. 1 atom plus 3 atoms. That is 4 atoms in our cell. Okay. So now let's figure out the mass of 1 atom. Or let's figure out the mass of 4 atoms. How about that? Okay. So we have 4 atoms. All right, and we know that 1 mole of silver has a particular mass, and that mass is 107.9 grams. That's just the molar mass of silver. Straight from the periodic table. And we also know that 1 mole contains 6.022 times 10 to the 23rd atoms. So remember, we're really interested in the mass of individual atoms. We're not interested in the mass of a mole, because we're going to be able to calculate the volume of a unit cell, so we need the mass of 4 atoms. Okay? So that gives us 7.167 times 10 to the negative 22nd grams. Does that make sense? Yeah, that makes sense. This is a really small mass, 10 to the negative 22. But this is just the mass of 4 atoms. And remember, there's 4 atoms in our unit cell. So that's the mass, I should say 4 silver atoms. That's the mass of all the atoms total in our unit cell. Okay, now let's do the volume. Let's calculate the volume of our unit cell. And if we look back to the top, We need it in grams per centimeter cubed. We have the side in picometers, so we got to go from picometers to centimeters. All right, so we have 407 picometers, and you can just look up, there's 10 to the negative 12th meters per 1 picometer, but that gives us meters, we want centimeters, and there's 100 centimeters per 1 meter, okay? Excuse me. That's going to give us the length of one side in centimeters. 407 times 10 to the negative 8 centimeters. Okay? So now, that's not our volume. That's just the length of one side in centimeters. So volume for a cube is length cubed. So all we have to do is take that 4.07, excuse me, times 10 to the negative 8th centimeters, and we cube it. And we get 6.742 times 10 to the negative 23rd centimeters. Okay, now all we need to do is calculate our volume, or I'm sorry, our density. Remember density? And that, by the way, this is the volume of the unit cell. Okay, density is equal to mass over volume. All we have to do is take our mass, which is up here, divided by our volume. So we get 7.167 times 10 to the negative 22nd grams over 6.742 times 10 to the negative 23rd centimeters cubed. And that comes out to 10.6 grams per centimeter cubed. Okay. Now that's not a measured volume. That's a calculated, or density. Excuse me. That's a calculated density. The measured density pretty close is 10.5 grams per centimeter cubed. Now, like I said, pretty close, but why the difference? Well, if we think about the lattice as just a series, again, just two-dimensional, and it's packed like this, well, every once in a while we might just miss one. It's called a defect. Okay, there might be impurities in the silver. It's difficult to get 100, absolutely 100% pure, but probably more likely it's that little defect in the unit cell where we're missing an atom. Gives us a very slightly lower density than what we would expect. All right, that'll do it for chapter 13, guys. Oh, good news. I forgot to put this in the announcement. No homework for chapter 13. We're done with homework.